Today I was going to talk with you about solving rational equations. Trying something new here, so bear with me. I was going to run through the notes and try to explain in case it helps you. When we solve a rational equation, the key is to add or subtract until there's just one fractional or rational expression on each side of the equal sign. Okay, once we do that, we can just cross multiply. And it's like the problems you've been doing forever. So let's look at our first example. In this first example, example 1, if we have 3 over 5x equal to the quantity 2 over x minus 7, it's pretty straightforward. One fraction on each side, we just cross multiply and then solve. So we take 3 times the quantity x minus 7 equal to 2 times the quantity 5x, distribute, solve. Now, once you solve, you need to make sure that that answer is not extraneous. In fractions, what would make an answer extraneous is if you end up dividing by 0. So you want to make sure the denominator does not become 0 when you plug in the solution, okay? When I plug in -3, I find out I'm good because I get 3 over -15 equals 2 over -10. Those are equivalent fractions. Makes my equation true like a solution should. So we box our answer and move on. Okay, in the next example, example 2, we have to simplify it down so that we have just one fraction on each side. Because remember, that's our goal, one fraction on each side. When I look at this one, I notice that the denominator is the same in 2 of my fractions on opposite sides of the equation. I can treat this just like any other term in algebra and just move it to the other side by doing inverse operations. So the opposite of plus is minus. I subtract the 10x minus 2, move it to the other side. Once I do that, because there's a common denominator, I can just subtract the numerators. So I end up getting the quantity 5x minus 10 over the quantity x minus 2 equals 7. Now, since I want to cross multiply, I'm going to turn 7 into a fraction. So I just put 7 over 1, and then I cross multiply, just like before, and then I solve. Again, I want to make sure my answer is not extraneous. So I take the 2 and I plug it back in. When I do that, I notice I get 2 minus 2, which gives me 0. Since we cannot divide by 0, that answer is extraneous, and our actual solution is no solution. Okay, the 2 makes the denominator 0. It does not work. Okay, example 3. Again, I look at this problem, and I notice that there's a 2x denominator on both sides. So I'm going to, once again, use inverse operations to move it to the other side. I add the 5 over the 2x. Simplify it down so that I have one fraction on each side. Once I have one fraction on each side, we cross multiply. When I cross multiply, I end up with the quadratic expression. I get 6x squared equals 8x plus 8. To solve this, we move, anytime it's a quadratic, we move everything to one side, set it equal to 0, and we start factoring. Remember, it makes your life easier factoring if you pull out the GCF. So I say 6, 8, 8, those are all divisible by 2. I pull out my GCF, and then I start breaking down my parentheses. So in my first set of parentheses, I write 3x, second set I write x, and then I say, oh, what multiplies to give me -4? What are my choices? What's going to work? Break it down. I get 2 and -2/3 as my solutions. Once again, check for your extraneous solutions. Because there are none, I have 2 answers this time. Okay. Okay, example 4. This time, I can't just move a fraction to the other side and combine to get it down to one fraction on each side. So what I'm going to do is I'm going to simplify the left-hand side of my equation to get a common denominator and a single fraction. To do that, remember, I multiply by whatever is missing, and I multiply by it over itself, because then I'm really only multiplying by 1, and I'm just creating an equivalent expression. I'm not changing the number, actually. So 2 over x, I multiply by 3 over 3, and then the 4/3 I'm going to multiply by x over x, because really, remember, that's just multiplying each expression by 1. Okay, simplify, and now I have 6 plus 4x over 3x equals 2. Remember, I want to be able to cross multiply now, so I put 2 over 1, and then I just cross multiply and solve. Once again, check to make sure it's not extraneous. It's not. I can actually make sure my answer is correct. I box my answer and move on. Okay, Example 5 and example 6 get a lot harder, so you can replay this if it helps, okay? On example 5, I look at this and there's no common denominator, so I have to start by combining my fractions on my right-hand side so that they have a common denominator and can be simplified into a single fraction. Now, like I said, it's the same process every time. So I multiply by whatever's missing over itself because that's really creating an equivalent expression because I'm just multiplying by 1. So you'll notice I multiplied the first fraction by n squared over n squared. I multiplied the second fraction by n plus 5 over n plus 5. Okay, then I'm going to distribute and write my new expressions. You'll notice that I recognize that the fraction on the left-hand side of my equation is actually the same as the fraction on the right-hand side of my equation. This is really important, and it's going to save you a lot of headaches and having to factor things you don't know how to factor, because I don't want to cross-multiply in this situation. If I was cross-multiplying in this situation, I would end up with an n to the 5th. That would be really messy, not fun. So when it gets too big, you always have the option of, if the two fractions on both sides of your equation have equal denominators, you can just set the numerators equal. I mean, think about it. 3/4 is equal to 3/4, okay? 2/5 is equal to 2/5. So if the denominator is the same, we just set the numerator equal and solve. Okay, so I drop out my denominator, I set the numerator equal, and I'm like, now I only have a quadratic to deal with and not a 5th exponent. Subtract the 5, I get 4n squared plus n. Pull out my GCF, finish solving. Remember to check for extraneous solutions. 0 is extraneous, okay? So I cross it off, it's not considered a solution, and when I box my answer, I just box the negative 1/4. Okay, one more example on just canceling out the denominator. Okay, when I look at this one, I say, okay, I can't just move something to the other side to simplify it. I want my denominator to be equal. So I start by combining the left-hand side down to a single fraction, okay? To do that, I'm gonna factor that expression in the middle because I don't wanna get larger and larger and larger exponents if I can avoid it. So when I do that, I know that n squared minus 5n minus 6 factors into n minus 6 times n plus 1. Which means that really the only part of that my first fraction is missing for the common denominator is the n minus 6. So I multiply by n minus 6 over n minus 6. Then I simplify that expression down. Now, once again, I don't want to have to make it bigger and bigger and bigger because that's not fun. So when I look at this, I'm like, oh, my right-hand side of my equation is just missing the n plus 1 part. So if I multiply by that, top and bottom, then my denominators would be the same, and I can ignore them. That's what I'm going to choose to do because I think that's a lot easier than getting bigger and bigger and bigger exponents. So I multiply by n plus 1 over n plus 1. Now that my denominators are the same, I just ignore them, drop them out, and solve just the numerator part. I go back and make sure that it's not extraneous. It doesn't make any of my denominators 0, so I'm good. I box my answer and I move on.